Hello everyone, today we have been discussing rapid sand gravity filter. So in rapid sand gravity filter, the water is come from the sedimentation tank. The water from the sedimentation tank is come and get accumulated over the filter media in the filter. In filter media, the water is accumulated over the filter media, and filter media is supported by the gravel layer. Generally in rapid sand gravity filter, we have confused between the filter media. So filter media is only sand, and to provide the support over the sand, to provide the support to the sand, we have provided the gravels layer. So gravels layer is only a support which are provided to the filter media. Filter media is of a sand in a rapid sand gravity filter. So water come from the sedimentation tank and just go through this filter media. The accumulated water which have particular head over the filter media, which seeps through the filter media and go through the gravel layer and finally get to the main pipe in a under drain pipeline, and we have get a filter water from the wall number 4 to water. सबसे पहले वाटर वॉल नंबर 1 से इंटर किया था, सेडिमेंटेशन टैंक से जो वाटर आया हमने उसको फिल्टर करने के लिए वॉल नंबर 1 से इंटर करवाया. वाटर कुछ हेड रिक्वायर करता है इस फिल्टर मीडिया के ऊपर टू सीप थ्रू द फिल्टर मीडिया एंड फाइनली गेट कलेक्टेड एज अ फिल्टर वाटर फ्रॉम द वॉल नंबर 4, और वॉल नंबर 4 से हमें फिल्टर वाटर मिला. सो दिस एंटायर प्रोसेस वी हैव सम ऑपरेशन ट्रबल इन द ग्रेविटी सैंड rapid sand gravity filter. The operation trouble is sometimes the impurities get entrapped between the voids of the filter media and the gravel layer. So for this purpose we have to perform the cleaning of the filter. To perform the cleaning of the filter, the water storage, wash water storage and the air compressor are provided, which are from the wall number 5. The water from the wall number 5, the air compressor from the air is passed to the filter layer of a gravel and the sand. So first of all air is passed and then fill wash storage water from the wall number 6, from the laterals and the mains go to the gravel layer and sand, and finally get from the wall number 4 and get to the wash gutter. So finally we perform the washing. We have performed the backwashing or the cleaning of the filter media, and water is from the wall number 6 water is get impurities and finally collected from the wall number 2 and wash away in a wash gutter. So in this way we perform the backwashing or the cleaning of the rapid sand gravity filter. So operation is first to get the filtered water from the wall number 4 and the water which is required. It is only the filter water which is we use to perform the cleaning of the filter. So for the cleaning of the filter, water is flow in upward direction from the gravel layer to sand layer and finally get collected from the wall number 2 and wash away in the wash gutter. So in this way we do the cleaning of the filter media. This is the whole operation we have take to perform the water to be filtered. सो ऐसे हम वाटर फिल्टर किया और क्लीनिंग किया. सो क्लीनिंग जो किया, क्लीनिंग इसलिए किया क्योंकि जो वॉइड्स हैं, जो हमारे सैंड लेयर की वॉइड्स हैं और जो ग्रेवल्स की वॉइड्स हैं, उनके बीच में इम्प्योरिटीज इंट्रैप्ट हो जाती हैं. इसको वॉश अवे करने के लिए हमने उसकी क्लीनिंग किया, जो कि हमें 24 to 48 आवर में करनी होती है। और इस पूरी बैक वॉशिंग प्रोसेस के लिए टोटल टाइम लगता है 15 to 30 मिनट। 15 मिनट to 20 मिनट तक बैक वॉशिंग इज completed in 15 to 20 minutes. The whole the back washing is completed. So water is come from the sedimentation tank and get accumulated over the filter media and finally seeps, and from the drain we have collected to the wall number 4, and we have performed for this process some type of impurity or get entrapped between the voids of the filter media. To avoid this because what is the problem is that प्रॉब्लम क्या है कि इसमें इंटरप्ट हो जा रही है इम्प्योरिटी, दिस इज द प्रॉब्लम। तो इस प्रॉब्लम को सॉल्व करने के लिए हमने बैक वॉशिंग की टू क्लीनिंग आउट द इम्प्योरिटीज। टू क्लीनिंग आउट द इम्प्योरिटीज हमने बैक वाटर यूज किया और उसको वॉश वाटर में बहाया। इसके बाद क्या हुआ कि प्रॉब्लम क्या थी, जो इम्प्योरिटीज थी जो इंटरप्ट हो गई थी इन वॉइड्स के बीच में, इन इम्प्योरिटीज को हटाना क्यों जरूरी था, क्योंकि दिस आर इंटरफेयरिंग विद द ऑपरेशन ऑफ द फिल्टर्ड वाटर। दिस आर द ट्रबल विच वी हैव फेसिंग टू फिल्टर द वाटर। टू अवॉइड दिस वी हैव टू डू द क्लीनिंग। frequency of the cleaning of the filter media or the gravel layer is 24 hours to 48 hours. After this we have a sand layer which are generally provided is 0.90 meter. This is the filter media. To support the filter media we have a gravel layer. The gravel layer is 0.90 meter which we have provided to support the filter media as a gravel layer which is 0.60 meter. तो इसमें होता क्या है कि जो इम्प्योरिटीज है, इम्प्योरिटीज इन वॉइड्स के बीच में आ गई है, these are offer a resistance to flow the water through the media. These impurities get offer a resistance and the filtration rate of the filter media is drastically reduces. So to avoid this we have performed the back washing and cleaning of the filter media. So effective size of sand particle which are generally used for rapid sand gravity filter is 0.35 to 0.55, which are greater than the rapid slow sand gravity filter. In slow sand gravity filter the D10 size of sand of particle which are mainly present or which are mainly present as a particle in a filter is D10, which are in slow sand filter 0.20 mm to 0.30 mm, which are lesser than the rapid sand gravity filter as a effective size of particle for a sand. The coefficient of uniformity for the rapid sand gravity filter is 1.2 to 1.8. Rate of filtration is 3000 to 6000 liter per meter square per hours. And minimum number of units are present at the time of treatment, which are computed by the empirical formula, which is 1.22 in root of Q mLT. So to perform the filtered water, to get the filtered water, we have some design which are present at the below level of a gravel layer in under drain pipes. The under drain pipes are main pipes and lateral pipes which are designed like perforated drains which require high velocity and air is not used in perforation drains, but in strainer types of drains low velocity and air is required. So lateral drains and the main drains are provided which are embedded in the concrete bed which are below the gravel layer. From this backwash water is come from the upward direction, from downward to upward direction to perform the backwashing or the cleaning of the filter media and to filter the water in the reverse direction. So from the rapid sand gravity filter, again we have discussed over the filter media. What happened to the filter media is we have discussed it further on. So what happened over the filter media? The filter media is sand. So this is the filter media. So this is the filter media sand we have provided over the gravel layer in the gravity sand filter. So in gravity sand filter we have provided the filter media sand over the gravel layer to perform a filtered water. To get the filtered water from the filter, we have required some head over the filter media. So this is the head required over the filter media. So the head to get the filter media, the head is constant head or varied head. So constant head, when we use constant head, we get the varied flow. We get the varied flow over the filter to get the filtered water over the filter media. And when we varied the head, we get constant water, filtered water. In this two types we have performed. First is we have to achieve a varied flow. We have constant head and get a varied flow. And second option is varied the head to get the constant filtered water. So over the filter media, water head is constant. Sometimes 1.2 meter to 1 meter is generally we have prefer over the filter media as a head required to sieve the water over the filter media. So this head, when finally get to go through the filter media, it's from the voids get entrapped the impurities. So when the impurities are entrapped between the voids of the filter media and the gravel media, the static head resistance of the filter media and the water head required over the filter media is get equal, and the vacuums are created over the filter media, and this is called the negative head. So this has to be avoided by requiring the minimum head, by providing the minimum head over the filter media, which is equal to 1.2 meter or 1 meter over the filter media, which is the constant head, and we provide the constant head, we get the varied flow. Varied flow because sometimes impurities are get entrapped between the filter media, and this is called the trouble to water to filter from the filter media, and filtered capacity of the filter media get reduces in constant head. So in constant head, when we provide the constant head, the filtered capacity is reduced because of the entrapped impurities. But in varied head, when we provide varied head, when the static head of water is equal to the resistance offered by the sand layer, is get equal and vacuums are created, and in that time only we have to provide the extra water over a particular this pre-selected head. So on this pre-selected head, in this pre-selected head, we provide extra depth of water as a head over the filter media to counteract the resistance offered by the filtered media sand. So this sand is offered the resistance. To counteract this, we have to provide the extra head so that the filtered capacity is increased. When filtered capacity is increased, when we provide the head over pre-selected head, we provide the extra head so that water can speedily go through the filter media. However, sometimes some impurities are get impurities are entrapped between the voids. But to avoid this, we have a certain amount of pre-required water. Above the pre-required water, we provide the extra water. So this is the head varied, but have a constant filtered water. समटाइम्स क्या होता है, इन दोनों के बाद ये जो फिल्टर यहाँ पे हमने जो वाटर यहाँ पे यूज किया है, ये यहाँ पे फ्लक्चुएट करते हैं, या तो कांस्टेंट रेट देंगे या फिर वेरिड रेट देंगे, जैसा भी रिक्वायरमेंट होता है वैसा हम यूज करते हैं. So for sand particle, we have a particle. To analyze the sand particle, sand media, we have a sand particle, and beyond force is acting over the particle, over the sand particle. So beyond weight क्या होगा? Beyond weight is equal to weight of the particle to the beyond force, which is act on the upward direction, and weight is act on the downward direction. This weight is act in the downward direction. Beyond force is acting upward direction. So balance this, we have the beyond weight. So beyond weight is the weight of the particle, which is the volume of solid from the relation of unit weight is equal to weight upon volume. From this relation we have got the volume of solid, unit weight of solid minus times of unit weight of water is exactly same the unit weight of solid, which are displaced by the water particle into unit weight of water. Volume of solid, unit weight of solid minus unit weight of water. If we divide and multiply unit weight of water over this relation to unit weight of water, volume of solid into unit weight of solid upon unit of water minus 1. So this relation where the beyond weight is equal to volume of solid, unit weight of water, G minus 1. This is important and asked in any exam. Beyond weight of water. So this is the porosity. Sometimes porosity get reduced because of the some kinds of impurities are present. These are the arrangement of the voids over the filter media. So impurities are get accumulated here. These impurities. So this reduces the porosity. The porosity get reduces. So porosity get reduces. So porosity reduces because of this entrapped impurities. So to perform and to avoid this, we have performed the backwashing or the cleaning of the filter media. So for this purpose, when the some types of impurities get imputed, the bed of the filter media, this is the bed of the filter media, which are provided by ours, is the filter of a sand. So this sand we have provided as a filter media. Filter media is the sand which are provided in the rapid sand gravity filter. So this get expanded into the impurities, and when the backwashing is, we perform the backwashing, the bed is expanded and the filter media. This bed all are expanded and have a more voids. Size of the void is more than the previous voids. So from this concept, 1 minus n, this is the porosity, is equal to 1 minus porosity is volume of void upon volume of the soil, total volume. So volume of porosity is volume of void to the total volume. So volume of solid is equal to total volume 1 minus n. So in this way, the pressure difference is equal to nothing but the beyond force which are acted over the particle. So pressure difference is unit weight of water, head loss between the difference between the acting forces between the two particles into area into these are the volume, total volume, which are at in this case A into D, area into diameter, 1 minus n, unit weight of water G minus 1, which are we have selected from this beyond weight. Beyond weight is equal to difference between the pressures. So from this relation we have equate this to each other and get a head loss which are direct. to achieve constant flow from the rapid sand gravity filter. To achieve a constant flow over a rapid sand gravity filter over the sand layer, a certain depth of head is provided. Over the sand layer, certain depth of head is provided. Since impurities are got entrapped between the sand particles, the rate of filtration is decreases. Since the impurities got entrapped between the sand particles, the head loss is increases and the rate of filtration is decreases. So head loss is increased and due to impurities, rate of filtration rate is decreased. So filtration rate decrease, head loss is increased due to the impurities which are got entrapped between the sand layers. To achieve the constant rate of flow, this is decreasing, rate of flow is decreasing, rate of filtration is decreasing. To achieve the constant flow, we have provided the certain depth of flow over the certain depth of flow. Depth of flow or water over a pre-selected head. This is the pre-selected. So over the pre-selected head, we provide the extra depth of water over the sand layer to achieve the constant rate of flow from the filter. To achieve the constant rate of flow from the filter, we have provided the extra depth over the pre-selected head. Because of the impurities, head loss is increases and rate of filtration is decreases. Rate to achieve this as a constant rate of flow, we increase the height of the flow over the sand particle. Sand layer is generally 0.90 meter in rapid sand filter. So this is about the rapid sand filter. In rapid sand filter, in this whole filtration process, the static head media resistance is equal. Head media resistance is equal. This is the minimum designing criteria for rapid sand gravity filter. This is the minimum design criteria for rapid sand gravity filter. If these are equal, media resistance and static head are equal. If this exceeds, this report is not our syllabus. So this report is not in our range. So we provide extra head or provide the backwashing. So through the backwashing, from the washing tank, water is come from the wall number 6, which we have discussed earlier. From the wall number 6, water is come from the wash water through the laterals and the main pipes. It is passed through the gravel layer and enter into the sand layer and wash away the impurities which are got already entrapped in the filter media and wash away in wash gutter. This is how the backwashing is done and this is how the rapid sand filter is completed. In slow sand filter, the rate of filtration is 24 to 48 meters cube per meter square per day. The rate of filtration for slow sand filter is 24 to 48 meters cube per meter square per day. The size of sand particle in slow sand filter is less than the rapid sand filter. In slow sand filter, the size of sand particle is 0.2 to 0.3 mm. But in rapid sand gravity filter, the size of particle is 0.3 to 0.55 mm. The slow sand filter is not used if turbidity is greater than 50 NTU. If turbidity of the raw water is more than 50 NTU, we not use the slow sand filter. In slow sand filter, rapid mixing is not induced, coagulation is not performed in the slow sand gravity filter. The frequency of cleaning is 1 to 3 mm in slow sand filter and coefficient of uniformity used for the sand particle is 5 for the slow sand filter. In rapid rapid sand gravity filter rate of filtration is 3000 to 6000 liter per meter square per hour, and the sand size particle is 0.30 to 0.5 mm, which we have discussed earlier. In coefficient of purity for the rapid sand filter is 1.2 to 1.6. The raw water we have collect from the source, go through the screening. Rapid mixing is induced in rapid sand gravity filter. In slow sand filter, rapid mixing is not induced, coagulation is not performed because of the size of the sand particle is already very less in the slow sand filter. Rapid mixing is induced in rapid sand gravity filter, and the slow mixing flocculation are formed in the rapid sand gravity filter. After flocculation, we have sedimentation, filtration, and finally disinfected the filtered water. The operation trouble in rapid sand gravity filter are mud ball formation. What happens is, in the gravel layer, some types of mud balls or the layer of a mud is formed on a gravel layer. This is avoided by the backwashing, or we have spread the potassium hydroxide over the gravel layer to avoid the mud formation. But during the time of backwashing in a gravel layer, it interfere with the evenly distribution of backwash water. To evenly distribute the backwash water over the filter media, it is interfere with the backwashing. To avoid this, potassium hydroxide is used and backwashing is provided to dislodge the impurities which are entrapped between the filter media and the gravel layer. So this is the mud ball formation, which is the first operation trouble we have faced in rapid sand gravity filters. In air binding, when the static head media resistance is equal, this is the minimum designing criteria which we have expected or permissible in the designing of the filter. If this exceeds, the report is not in our favor, and the negative head is developed between the filter media, and this is the problem in our filter process. This whole process where the operation is taking place is the procedure of the filtered water, and the cleaning of the filtered water is called the operation trouble, where the backwashing is provided and the filtered water is collected. अलग-अलग चैम्बर में दोनों हम फिल्टर्ड वाटर अलग कलेक्ट करते हैं और वॉश वाटर को अलग डिस्पोज करते हैं. Cracking of the filter. Third is cracking of the filter. The operation trouble is the filtered bed is cracked, and this is due to the alternate wetting and drying of the filter media. This is how the crack is happening in filtered bed. The expansion in filter media and erosion of the sand particle. The filtered media is the sand. The erosion of the sand particle is taking place in the rapid sand gravity filter. This is the problem in our rapid sand gravity filter we are facing. To avoid this backwashing, when the backwashing is done from the wall number 6 through the lateral and the main pipe, the upward direction of flow is provided, and passing through the gravel layer, it passes through the media of a sand layer, and as a wash water, these are dislodged to the impurities are dislodged to the wall number 2, from the wall number 2 to wall gutter. So sometimes the impurities are then get entrapped and wash away the porosity of the media increases and effective stasis decreases. The effective stasis are decreases, the porosity increases, the voids is more than their prior size of the voids. So this time voids are more, effective stresses are decreases, so sand particle is washed away and go through the wash screws which are provided near to the media of a filter. So media of a filter is very near to the wash screws, buffles. The buffles is the pattern which are the pattern is provided as a design criteria for the wash screws. So on the wash screws, the erosion sand particle are washed away and finally get collected into wash gutter. So this is this is how the erosion of a sand particle, which is the media provided for the filtered water, which are washed away from the media or the separated from the filtered media. Sometimes some amount of sand is washed away through the wet washing also. So this is to be avoided. So this to be avoided, and this is the operation trouble which we are facing in rapid sand gravity filter. So this is the operation trouble with rapid sand gravity filter. These are the working which are constant flow and buried head, which to achieve the constant rate of filtration. Here the rate of filtration is decreases, head loss because of increases. The rapid sand gravity filter and slow sand filter, which are, you have to remember, this is the data which is given, and you have to remember the data for the rapid sand gravity filter